The Pythagorean Theorem. The Pythagorean Theorem says that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. The legs are the sides A and B. It doesn't matter which one's A, which one's B, they're interchangeable. These are the legs. The hypotenuse, remember, is always opposite the right angle. The hypotenuse is always the biggest side because it's always opposite the biggest angle. Biggest angle of a right triangle is the 90 degree. The hypotenuse is always opposite the 90-degree angle every single time. The sum of the squares of the legs is equal to the square of the hypotenuse. You probably know as a squared plus b squared equals c squared. Again, c being the biggest side, always opposite the right angle. The Greeks thought of the Pythagorean theorem in terms of area. In the picture, each side creates a square. This one is a times a squared is the area, base times height. This one is b times b squared is the area. And this one is c times c squared is the area. It is true, as the Greeks thought of the Pythagorean theorem, that the area of a squared plus b squared equals c squared. Any whole numbers, any triple of whole numbers that works in Pythagorean theorem is called a Pythagorean triple. The first and most common one is the 3, 4, 5. Notice that 3 squared plus 4 squared equals 5 squared because 9 plus 16 is equal to 25. Any triangles with the same ratio also make a triple. So if I double them all, a 6, 8, 10, that's also Pythagorean triple because 6 squared plus 8 squared will equal 10 squared. You could multiply them all by 3, and that would be a 9, 12, 15. That will also work in Pythagorean theorem, but they don't have to be in that ratio. There are lots of others that work. For example, a 5, 12, 13 is a Pythagorean triple because 5 squared plus 12 squared is equal to 13 squared. 25 plus 144 is equal to 169. When using the Pythagorean theorem, most of the time our three numbers aren't going to be whole number triples, Pythagorean triples. We're going to have decimals and square roots, and you need to know how to work with both. We can find either the hypotenuse or one of the legs. Remember, A and B, you can interchange them. It doesn't matter, you're going to square them and add them. It doesn't matter which one A and B is. However, C is always the hypotenuse, the biggest side. So we can find the hypotenuse by plugging in a squared plus b squared equals c squared. That's 5 squared plus 8 squared is equal to c squared. 25 plus 64 is equal to c squared. 25 plus 64 is 89 is equal to c squared. Then to find c, we take the square root of both sides. The square root of c squared is c, and the square root of 89, we're going to round to the 10th, is about 9.4. We can find a leg, but we have to subtract to find a leg. But first of all, plug it in a squared plus b squared equals c squared. This becomes 9 squared plus b squared, we don't know b, equals 17 squared. 81 plus b squared equals 289. To get b squared by itself, we subtract 81 from each side. We get b squared equals 208. And then to find b, we take the square root of both sides. And the square root of 208 is, rounded to the 10th, 14.4. A lot of times in upper level mathematics, we want to have our answer exact, and that's where we put it in simplest radical form. We're not going to use decimals here. Our answer won't be a decimal, it'll be a square root. If you've forgotten how to simplify square roots, there are a few examples in the video for review, which I'll explain then, and I'll talk a little bit about it now. But just like we did the others, we're going to plug in a squared plus b squared equals c squared. That's 10 squared plus 5 squared equals c squared. 100 plus 25 is equal to c squared. 125 then is c squared. Square root both sides, no decimals. To simplify a root, we look for the largest perfect square in the root. Perfect squares are the numbers like 4, 9, 16, that's 4 times 4, 5 times 5, 25, 36, 49, and so on. So we want one of these that divides evenly into 125, and 25 does. Turn 125 into 25 times 5, that's the same thing. And I can take the square root of 25, let's write it this way. C equals the square root of 25 times 5, that's 125. We can take the square root of 25, it's 5. Left underneath is this 5 that I couldn't take the square root of. So the answer is 5 root 5, or you can also say 5 radical 5. And that answer is exact. Another example, a squared plus b squared, that's 8 squared, equals c squared, that's 16 squared. A squared plus 64 is equal to 256. Take a 64 off each side. We're getting a squared by itself. A squared equals 192. Take the square root of both sides. Now we're looking for the largest perfect square that divides into 192. So we would just start going up the list. Now 192 divided by 4 is 48. Now if you're thinking, well, 4 is a perfect square, it's 4 times 48, I'm going to point out that there's a bigger one. I can tell that because there's still a 4 in 48. That means there's got to be a bigger perfect square. 48 is 4 times 12. So at the very least, 4 times 4, 16 is in there. So I'll write 192 is 16 times something. It's 16 times 12. But again, 12 still has a perfect square in it. It's 4 times 3. So if I take 4 times 16, I'll get the biggest perfect square. In fact, that's 64. 192 is 64 times 3. So a squared is 64 times 3. The square root of 64 is 8. So 8 root 3 then is my answer. Now, if that was clear as mud, go to the examples in the video later and watch those 3 examples, and I'll show you another technique to find that biggest perfect square using a factor table. Another use of the Pythagorean theorem is to tell whether a triangle is right or not. The Pythagorean theorem says that if a triangle is right, then a squared plus b squared equals c squared. The converse is also true. If a squared plus b squared equals c squared, then the triangle is right. So that is how we can tell it's right. If it works perfectly in the Pythagorean theorem, then we know it's a right triangle. Well, we have other theorems that add on to that. These are the Pythagorean inequalities theorem. And what it says is that if I make my C longer, now look at the example for the obtuse triangle right here. If I make my C longer, what that does is makes this right angle bigger. And it makes it an obtuse triangle. So if C squared is greater, that makes the 90-degree angle greater, and I know it's obtuse. And look at in red below. If I make my hypotenuse, no longer the hypotenuse by the way, because it's not opposite a right angle, but my C smaller, then that makes the angle smaller. So if my C is shorter, if it's less than a squared plus b squared, That means the triangle is acute. So this picture right here, that's the key to understanding. If you make your C bigger than a squared plus b squared, that makes the angle greater than 90. If I make my C shorter than a squared plus b squared, that makes my angle less than 90. Here are a few examples on applying the Pythagorean inequalities theorem. We know C is the biggest side, so there's my C, there's my C, and there's my C. Reminder, if C squared equals a squared plus b squared, I know that it's right. If C squared, if I make my hypotenuse longer than a squared plus b squared, it's obtuse. If I make my hypotenuse, my C squared, shorter than a squared plus b squared, then it would be less than 90 and it would be acute. So let's start off with our C then. We're going to compare C, the biggest side, 13 squared, to 5 squared plus 12 squared. Well, this is 169, and this is 25 plus 144. Now, 25 plus 144 is 169, so these are equal. So I know that this one is right then. On the next one, I'm going to compare my C, 20 squared, with 9 squared plus 12 squared. I do want to point out, you need to be careful that it's actually a triangle. Remember the triangle inequalities theorem that said the sum of any two sides must be greater than the third? 9 plus 12 is greater than 20. The two smallest sides must be bigger than the biggest side. So this is a triangle. So we're okay there. 20 squared is 400. 9 squared is 81. And 12 squared is 144. 81 plus 144 is 225. So 400 is greater than 225. My C squared is greater. That means this one is obtuse. For my last one, I'll compare my C, 9 squared, with 6 squared plus 8 squared. Again, the sum of any two sides is bigger than the third, so it is a triangle. 81 and 36 plus 64 is 100. 81 is less than 100, so C squared is less. This triangle must be acute. Here are examples from your assignment. Question 1. A right triangle has legs of length 6 and 8. Find the length of the hypotenuse. The hypotenuse is our C. We know that a squared plus b squared equals c squared. 6 squared plus 8 squared is equal to c squared. We need the hypotenuse. This is 36 plus 64 equals c squared, or 100 is c squared. Square root both sides, and c is 10. Here we're going to find q, which is the hypotenuse. This is our c. So we know that 20 squared plus 7 squared is equal to q squared. That's our c. 400 plus 49 is equal to q squared, or 449 is q squared. Square root both sides. We're going to round to the hundredth. That's 2 decimal places. Look to the third decimal spot to round. The result is 21.189, and that 9 will tell us to bump the 8 to a 9. So it's 21.19 to the hundredth. In question 4, we're going to find a leg. This is our A or B. You can interchange them, remember, and there's our C. So we know that j squared plus 7 squared is equal to 19 squared. J squared plus 49 is equal to 361. Get the j squared by itself. Subtract 49 from each side. So j squared would equal 312. And we're going to square root that to find j. And j will equal, to the 100th, 17.66. Before we simplify with square roots, we'll review working with square roots. Remember that when you simplify a square root, you use a perfect square. Any number times itself. 1 squared is 1. 1 is a perfect square. The square root of 1 is 1, but that's not useful in simplifying a square root. So the first one we care about is 4. That's 2 squared. 3 squared is 9. 4 squared is 16. 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and they go on forever. These first ones are the most important. We want to find the largest, you heard me say the largest perfect square that divides evenly into this number. Now, if you don't get the largest, that means there'll be a perfect square left in the remaining number after you divide out a perfect square. That's how you can tell. One way to get a perfect square is just to manually divide it, of course, and keep going and guessing and checking. But you can also use a factor table. And if you go to my classroom website, the link is in Google Classroom, and you click on Resources, you'll find a link to a Google factor table. Make your own copy of this, and all you need to do is enter the number you're looking for perfect squares into the spreadsheet, hit enter, and start looking for all these perfect squares. You want the biggest one possible. I'll show you what that looks like. I entered my perfect square in the box and hit enter, and then I start looking down this list for the largest perfect square. Now decimals are out. They're not going to work. We want perfect squares. Well, notice that 49 is a perfect square, and it's 49 times 5. And 5 is prime. It doesn't have any more perfect squares in it, so we know that 49 is the biggest perfect square that divides evenly into 245. 5 times 49. We'll rewrite this as 25 times the square root of 49 times 5. I can take the square root of 49. It's 7. Remember that there's times out here. When you say 3 root 2, it's just like saying 3x. 3 times x, 3 times root 2. This is 25 times that square root. The square root of 49 is 7. The 7 goes out front, and you have to multiply. 7 times 25 is 175. 175 root. Left underneath the root is the 5 that we couldn't do anything with because I can't take the square root of 5 unless I approximate. So the simplified answer is 175 root 5. This next one's a little easier because 300 is 100 times 3. Rewrite this as 100 times 3 for 300. The square root of 100 is 10. That 10 goes out front. There's times right here. 10 times 10 is 100. 100 root 3 then is my answer. 15 root 8. That's also an easier one. That first perfect square on the list, 4, is in there. So I'll rewrite 15 root 8. It's 15 root 4 times 2. I can take the square root of 4. It goes out front as a 2. 2 times 15 then is 30. And 30 root 2, or 30 radical 2, is your answer. In this problem, we're going to find the exact value in simplest radical form. No decimal. X squared, that's a squared, plus b squared equals c squared. X squared plus 11 squared equals 16 squared. That's x squared plus 121 is 256. Subtract 121 from each side. X squared equals 135. Now I'm looking for the largest perfect square in 135. There's a rule for divisibility for 3 and 9. It only works for 3 and 9. If you sum the digits of a number, 1 plus 3 plus 5 equals 9, and 9 or 3 divides evenly into that number, then 9 or 3 will divide evenly into the number you're looking at. So 9 divides this, I know that. 135 divided by 9 is 15. 15 is 3 times 5, both prime. There's no perfect squares in 15, so I know that 9 is the largest perfect square. I'm going to rewrite this as 9 times 15. I can take the square root of 9, it is 3, and 3 root 15, or 3 radical 15, is my answer. Another one in simplest radical form. A squared plus b squared equals c squared. X squared plus 7 squared equals 15 squared. X squared plus 49 is equal to 225. Subtract 49 from both sides is 176. Let's find the largest perfect square in 176. Off the top of my head, I'm not positive, but I see that it's even. Now, 2 is not a perfect square, but I divide it by 2 just to see what was left. It's 2 times 86. Now, 86 has another 2 in it, so I know at the very least 4 divides into it. So let's divide it by 4. 176 divided by 4 is 44. That's interesting. 44 has another perfect square in it because it's 4 times 11. So the biggest perfect square is going to be 4 times 4, 16. In fact, if you multiply two perfect squares, you get another perfect square. Handy thing to know. So this is 16 times something. 176 divided by 16 is 11. Yeah, I could see that right there, couldn't I? So x will equal the square root of 16 times 11. Square root of 16 is 4. 4 root 11 is my answer. I'm doing several of these because I know we need practice simplifying roots. X squared plus 11 squared equals 18 squared. X squared plus 121 is equal to 324. Get the x squared by itself. Subtract 121 from each side. 324 minus 121 is 203. I just tried several perfect squares dividing into 203, and I didn't find one. So I'm going to go to the factor table. Looking at the factor table, looking down the list, there don't seem to be any perfect squares. At some point as you go down the list, the factors will repeat. There aren't any perfect squares in 203, which means when I take the square root of both sides, this can't be simplified. So x is the square root of 203. Here's an application problem. TVs and computer monitors are often advertised using the diagonals. So if a TV, or a flat screen in this case, has a diagonal of 48, and the TV is 17 inches tall, then how wide is the screen? So this is my A or my B. A squared plus 17 squared is equal to 48 squared. A squared plus 289 is equal to 2,304. Let's subtract 289 from each side. A squared equals 2,015. Square root both sides. This says round to the 10th. So A is equal to, it's 44.88. So to the 10th, it'd be 44.9. And that would be inches. In question 22, we're just checking to see whether it's a right triangle or not. Does a squared plus b squared equal c squared? C squared is the biggest side, so that would be the 89. A squared and b squared are 39 and 82. Remember, you can exchange those, that doesn't matter. So we'll work this out on the calculator. 39 squared is 1,521. 82 squared is 6,724. 89 squared is 7,921. A squared plus b squared is 8,245. That's not equal to 7,921. This is not a right triangle. Another example. Does a squared plus b squared equal c squared? Does 45 squared plus 24 squared equal 51 squared? So I'll put this in the calculator. 45 squared plus 24 squared is 2,601. 51 squared is 2,601. Hey, that works. This is a right triangle. In question 29, we're going to see if this is obtuse or acute, or right. We know that C is the biggest side, so my C is 20. So C squared is 20 squared, and it doesn't matter the order of the other two. So I'll put this in the calculator. It is 433. 20 squared is 400. So C squared is less than A squared plus B squared, meaning the hypotenuse in a right triangle, if you shorten it, it's no longer a right triangle, it's acute. Acute is the answer. In this example, our biggest side is 13. So C squared is 13 squared. A squared and B squared are 4 squared and 12 squared. This is 169. This is 16 plus 144. 16 plus 144 is 160. So C squared is greater. When C squared equals A squared plus B squared, it's right. If we make C squared greater, then that makes it obtuse.